Hello guys, welcome back to Civil Engineering YouTube channel. Please subscribe our channel for daily civil engineering videos. In today's lecture, we are going to find out the support reactions for the beam when there is a triangular load acting on the beam and also when there is a moment acting on the beam. So the problem states that find the beam reactions for the beam is shown in the figure. The length of the uniformly varying load, the triangular load is distributed over the length of 3 meter and also the moment is acting at a distance of 5 meter from this left end with a magnitude of 2 kilonewton meter. So let's consider this is support A is hinge support and roller support is B. The hinge support has the property to resist the vertical load RA and also it can resist the horizontal load RAX. But in this case there is no horizontal load acting on the beam, so this component will be equal to 0. So we will only have to find out the vertical reaction of the hinge support. The second one is the RB here. So we have to find out these RA and RB. These both are the unknown support reactions for this B. Now to start with the finding out the support reactions, we have to convert this uniformly varying load into pointed or concentrated load. So how to convert this uniformly varying load to a pointed or concentrated load? Simply we will find the area of this triangle. So we will find the area of this triangle. So it will be area will be equal to the half base into height. This is the formula used to find out the area of the triangle. Now as we know that the half base is 3 meter and height is 2 kilonewton per meter. 2 kilonewton per meter. So this 2 will be cancelled, so we will remain only with the 3 kilonewton. So the magnitude of the pointed load or the concentrated load is 3 kilonewton here acting at the centroid of this triangular load, 3 kilonewton. Why we convert this uniformly varying load into a pointed or concentrated load? Because we will need this value of pointed load later on in the moment equation to find out the support reactions. That's why we always have to convert this uniformly varying load or distributed load into a pointed or concentrated load. The method is very easy. You simply have to find out the area of the triangle. If there is a trapezoidal load, you have to find out the area of the trapezoid. If it is a rectangle, you have to find out the area of rectangle. So this will be the pointed load acting at the centroid of the area. Now this load is acting at the centroid, so we have to find out the centroid of this triangle. So the centroid is this distance, and this distance will be equal to the 2/3 of the length. The length total is 3 meter, so it will be 3. So 3 will be cancelled, it will become 2 meter. So the distance from this pointed load up to A point will be 2 meter. Similarly, if you didn't understand that how I calculated this, let's consider this is in a triangle with the length of x. So the load will always act at the centroid of the triangle. It should be kept in mind that if it is a length of x, the triangle, so from this end it will be 2/3 of x. The centroid will be 2/3 of x, and this will be, the remaining portion will be 1/3 of x. This is the method how to find out the centroid of a triangle. So in the similar way, I found out by 2/3 of the x, which is 3 meter here, so it comes out to be 2 meter. Now it's really easy to find out the support reactions. The first step is to find out the pointed load. We found out 3 kilonewton, and the next step was to find out the moment arm, which we found out is 2 meter. Now let's consider that summation of moment is point A is equal to 0. This equilibrium equation is easy to find out the support reactions as we have two unknowns. Summation of horizontal forces we cannot use because we don't have any horizontal forces. Also, summation of vertical forces, we cannot use this equation because we have two unknowns, RA and RB. This equation can only be used when we have only one unknown. So the only equation that we can use here is summation of moment. And we consider the summation of moment at point A equal to 0. And let's consider the clockwise moment is taken as positive and anti-clockwise moment is taken as negative. This is just our sign assumptions. So starting the moment from this end, so the first load that creates the moment about point A is this concentrated load 3 kilonewton, and it acts in the clockwise direction about point A. So the clockwise direction is positive, so plus 3 multiplied with the moment arm. The moment arm is this distance from the load to the point A, which is 2 meter. The next moment is this 2 kilonewton meter, which is also acting in the clockwise direction. If you look to the sign, so it is also taken as plus 2. The next load that creates the moment about point A is RB, and it creates the moment in the anti-clockwise direction about point A. So it will be minus RB multiplied with the moment arm. The moment arm is the distance from this load up to this point, which is 2 plus 2 plus 3, which is 7. So summation of all the moment about point A equal to 0. Now if I shift this value into the right side, so it will be 7 RB equal to the 236 plus 2, simply 2. Now 7 RB comes out to be 8. So now RB will be equal to the 8 divided by 7. I simply shift this value into the right side, so RB comes out to be here 1.14 kilonewton. So this we find out the RB here 1.14 kilonewton, magnitude of 1.14. Now to find out the RA, we can use this equation because we have only one unknown. Also we can also use this equation that taking the summation of moment at point B equal to 0 or summation of vertical force is equal to 0. We can use these both equilibrium equation. Now let's try this method. So summation of vertical forces is equal to 0 on the beam, and upward force is taken as positive and the downward force is taken as negative. The upward force is RB and RA. Downward force are 3 kilonewton. This is not a force, but this is a moment. So we will not take this value. So summation of all the vertical forces is equal to 0. So RB, so RA comes out to be, if we shift this RB in negative 3 into the right side, so it will become 3 minus RB, or we can see 3 minus RB is 1.14. So RA comes out to be, if we subtract this value, so we got here 1.86 kilonewton. So this is the RA, 1.86 kilonewton. So we find out both the support reactions. So hope you guys understand how to find out the support reactions for the beam when there is a triangular load given on the beam, and also when there is a moment acting on the beam. And don't forget to subscribe our channel for daily civil engineering videos, and also if you have some questions you can also comment on this video. Thank you for watching our video.